So as we continue looking at derivatives, we're going to do one that's definitely a bit more involved than the previous examples. This one is a fraction, or a quotient, if you will. And we don't have any special rules yet for dealing with a quotient, a division problem. So unfortunately, I'll tell you what it isn't. We don't just do the derivative of the top and the derivative of the bottom and put those things together. It's not going to be as simple as that, which, as we're going to discover, is actually probably a good thing. So as we begin this problem here, then, since we can't do this as a division problem right now, our only choice is to break it apart. So we use our distributive property to distribute that denominator into each part of the numerator, and then we go through and we simplify those. X to the fourth over 8x to the third will just become 1/8 x. And when we get to 5x squared over 8x to the third, that's going to be 5/8. And then x to the second over x to the third, 2 minus 3, that's going to be 5/8 x to the minus 1. And because we're interested in doing the derivative, we do want to write that with a negative exponent as opposed to 5 over 8x. And then lastly, 3 over 8x to the third, we can write as 3/8. And then the x to the third, we can write as x to the minus third. Now this is set up in the right format so that we can go ahead and we can start doing the derivative, because now we're ready to do the power rule. And so we go ahead and do that. So the derivative of g would be the derivative of 1/8 x, which will just be 1/8, minus 5/8 times the derivative of x to the minus 1. Remember the power rule, multiply by the exponent, decrease it by 1. So it'll be times minus 1 x to the negative second, plus the constant 3/8 times, and then we do the derivative of x to the negative third. Multiply by 3, drop the exponent by 1, gets us down to x to the negative fourth. Okay, at this point, I'm going to do a little bit of rewriting, a little bit of cleaning up here. So 1/8, 5/8 times negative 1 will make that plus 5/8 x to the negative second, and then 3/8 and negative 3 will make that minus 9/8 x to the negative fourth. At this point, if you want to, we can just take those negative exponents and move them down to the bottom to get our answer, and that's okay. Our answer is written without negative exponents, so we're fine there. We don't have to go any further. However, there are going to be times later on in this course in calculus where we're going to prefer to have our answer written as a single fraction, because there are going to be certain things that we're going to want to do, whereas if it's written as a single fraction, it's easier to do those things and easier to check those things. And so I want to also revisit simplifying by factoring. So I'm going to go back to this problem here, and we want to pull out a common factor. Remember, the common factor is the smallest thing that is in each of them. Now, unlike the example I did before where I didn't worry about pulling out a numerical common factor, here I do want to pull out the fraction. So 1/8 is my common denominator for all the fractions. So I'm going to pull that out as well. And then the smallest power is x to the negative fourth. Okay, now when we factor, we got to say, okay, what do I have to multiply 1/8 x to the negative fourth by so that I get just 1/8? Well, it's going to turn out that's going to be x to the fourth. And let me show you why. So if we take 1/8 divided by 1/8 x to the negative fourth, the 1/8 of course will cancel out. And we'll have an x to the negative fourth in the bottom. That x to the negative fourth will need to slide on up to the top, and that's why we get x to the fourth that's left over. And then we continue on, now dividing the 5/8 x to the negative second by the 1/8 x to the negative fourth. And so, first of all, that's going to be plus 5, right? Because we can take the 1/8 out of the 5/8, so we're left with a plus 5. And then what about the variable? Well, our problem was 5/8 x to the negative second over 1/8 x to the negative fourth. Of course, the 8's cancel out, that's why we get 5. And then what about the variable? Well, we have x to the negative second over x to the negative fourth. Subtracting our exponents, be negative 2 minus a negative 4, we'll make it negative 2 plus 4. We'll make it a positive 2. So it's actually going to be 5x squared. And then the last one here, we take this negative 9/8 x to the negative 4, divided by the 1/8. So, of course, the 9/8 divided by 1/8 will just be minus 9. And then we have the x to the negative fourth and the x to the negative fourth, so they just go away. They just go away. And so we get 1/8 x to the negative fourth times x to the fourth plus 5x squared minus 9. And then what we can do to finish this problem off is take the 8, move it to the bottom, take that x to the negative fourth, move it to the bottom. And now our answer is written as a single fraction. Our answer is now written as a single fraction. And like I said, sometimes that's going to be preferable. We're going to be able to do things easier with our functions as we start looking at applications of derivatives when they're written sometimes as a single fraction like this.